Hello friends, my name is Akshans and welcome to CADDD Academy. In this lecture we are going to discuss about electric field due to point, line, surface and volume charge. Okay, so to understand this topic we must know what is point charge. Okay, what is point charge, what is line charge, surface charge and the volume charge. Okay, so I hope you all must be knowing about the point charge. A point charge is a charge at a single point. Okay, so let's say at this point we have a charge of q coulombs. Okay, q coulombs. Okay, at this point we have a charge of q coulombs. So as we know the electric field formula, which is 1 by 4 pi epsilon into charge by the distance square into the r cap. So this formula we have derived in previous classes. So this was the simple just a point charge, and this is the electric field due to the point charge. And what is this r? This is the distance between the point. Let's say we have to calculate the electric field at this point, which is p, so this distance is called r. Okay, so this is the electric field due to point charge. Okay, and now we will understand the line charge. Okay, this is line charge. Okay, as the name saying, line charge. Okay, let's say we have a line here and it has charges like this. This charge distribution on this line is uniform. So this line charge has some line charge density, which we will call it as rho L. Okay, so length, so the unit of this will be coulombs per meter. So let's take a small length dl, and at this dl we have the charge amount of dq. So this rho L, which is charge density, which will be equal to charge per unit length. Okay, so unit of this thing is coulomb and unit of this thing is meter, so the unit of this thing will be coulombs per meter, which we have seen here. Okay, so let's take this dl this side, and rho L dl is equal to dq. So dq is equal to, let's integrate both sides, rho L dl. Okay, so integration of 1 with respect to q will be q and rho L dot dl. Okay, so this is the value of q. Now we will put this value of q in the electric fields formula, and we will get electric field as 1 by 4 pi epsilon rho L dl, because we are writing this thing instead of this q. Okay, so by r square, and it has direction also, which is r cap. Okay, so this we will call it as electric field due to line charge. Okay, now the next thing is surface charge. Okay, surface charge. So again, as the name saying, let's say we have a surface. Okay, so this is the surface and it has charge, uniform charge. Okay, we are assuming to have a uniform charge over the surface. Okay, So now again we will do the same thing. We'll take a small amount of surface which will have charge of dq and the area of dA. Okay, and this surface charge will have surface charge density which will be coulombs per meter square. So here we will define the electric field at the point which is r distance away from the surface. So similarly as we done before, rho s is equal to dq by dA. Okay, charge per unit area is the charge density. Okay, similarly unit of this thing is coulomb, unit of this thing is meter square because this is area, and then the unit of this thing will be coulombs per meter square. So let's take this dA that side. We will get dq is equal to rho s into dA. Let's integrate both sides and we have q is equal to rho s and dA. Okay, now we will put this q value in the general formula of electric field. Okay, so the general formula of electric field is 1 by 4 pi epsilon, and we will write the value, q's value, this thing, instead of writing q because we have here surface charge. So this r is this distance and it has some direction also which is r cap. Now the last one is volume charge. Okay, so again we will take a, let's say we have taken this volume. Okay, this thing is showing that it's a volume. Again we will take a small amount of volume. Okay, like this, and this cube's volume is dV. Okay, this whole thing's volume is V, but this cube's volume is dV, and the charge enclosed by this thing is dQ. Okay, charge enclosed by this thing is dQ. This volume has enclosed some uniform charge inside it. Okay, like this. So charge enclosed by this volume is dQ and the volume of this volume is dV. So again doing the same thing, rho v is equal to dQ by dV. This unit is coulomb, this unit is meter cube, so this thing's unit will be coulombs per meter cube. Okay, and so taking this thing that side and integrating dQ, so dQ is equal to rho v dV, integrating both sides, and we have Q is equal to rho v dV. So this is the Q value, and we will put this in the electric fields formula, which is 1 by 4 pi epsilon, and we will put this thing instead of Q, so rho v dV by r square into r cap. So r cap, so this r is, let's say we have to calculate the electric field at this point, so this r is the distance between center of the volume, okay, and this r is the direction. Okay, this r cap is the direction.